Let's talk about simplifying expression. In this video, I'll go over identifying the terms and numerical coefficient. We will also identifying the like terms and unlike terms. We will combine the like terms, and we will also learn how to simplify expressions. Let's get started. Let's first know the difference between the terms and factors. In an expression x7x cubed plus 3x squared, we have two terms. 7x cubed is one term and 3x squared is a second term. Terms are always separated by either a plus sign or a minus sign. Now we have another expression, 7x cubed y squared. This is considered one term. X cubed y squared and 7, they're all considered factor. We do not see any plus or minus sign in between. This is a one-term expression. Let's first find the numerical coefficient. In an easy term, numerical coefficient is a number factor in the term. Here I have few examples. Let me show you how to find the numerical coefficient. My first example is negative 24y. Negative 24 is one factor and y is my second factor. The numerical coefficient, the number factor, is to a negative 24. Second example, I have xw. There is no number in the front of xw. If there is no number, there is always 1. And 1 is a numerical coefficient for xw. 8k squared, k squared is a variable, 8 is a number factor in the front. Numerical coefficient is 8. 3/5 times a is a variable. 3/5 is a number in the front. Numerical coefficient can be fraction also. In this case, it's 3/5. Let's try one more, b/7. Now, b is a variable. There is a 1 hidden in the front of the b. So, 1/7 is a fraction, which is a number in the front of the b. Let me write this again. It's 1/7. So, in a short form, the number factor in any term is called the numerical coefficient. Let's identify the like terms. Terms with exactly the same variable and same exponent are considered like terms. So you have to compare the variables first, and then you have to look at the exponent. If they both match, the terms are considered to be like. I'll give you a few examples here. 3x and 13x. Now remember, 3 and 13 could be different because those are numerical coefficient. I'm looking at the x and the x. Both have power 1. The variable is same. The exponent is same. These are like. 7y squared and negative 8y squared. Y squared and y squared. Exponent, variable, both are same. These are like. 17hk and 87kh. 17 and 87 are a numerical coefficient. HK and KH, letters are same. Now keep in mind, as far as the letters and powers are same, it could be in any order of your choice. They still will be considered like. Here's another example. 5m cubed n squared and negative 15m cubed n squared. We have m cubed on both the sides. We have n squared on both the sides. And therefore, these are like. Sometimes only numbers are given. There's no variable attached. If there's no variables attached, any kind of a number will be always considered like. Now let's look at some of the unlike terms. In unlike terms, you can have either a different variable or you can have a different exponent, or both can be different, the variable and the exponent. My first example, I have 3x and negative 5x squared. X and x squared. X are same, the variable, but the exponent are different. X has a power 1 and x squared has a power 2. That's what makes the first example unlike. Second example, 4y squared x cubed and 7x squared y cubed. Y has a power 2 on one side, the other side y has a power 3. X has a power 3 on one side and the other side x has a power 2. Even though the letters they have are same x and y, but the powers on that particular letter doesn't match. And therefore this is unlike. 11a squared and 11b squared. Exponents are same 2 and 2, but the letters don't match a and b. 11 is a numerical coefficient, keep in mind. We're comparing a and the b, the variables don't match and therefore it's an unlike term. Now, anything you want to combine, you have to make sure the terms are like first. So let's begin combining. Here's the first example. 4k plus 7k. When you combine, you don't touch the letter. You just have to make sure that they're like. So in this case, my variable k will stay as is. I will just combine my numerical coefficient 4 and 7. And that will result in 11k. Let's try another example. 4r minus r. There's a 1 in the front of the r, so they are like. I'll leave my r and then I'll subtract 4 minus 1, which will give me 3r. Let's try one more. 5z plus 9z minus 4z. They all are like because they all have a z in them. 5 plus 9 is 14. 14 minus 4 will be 10. The answer will be 10z. Let's try a few more. Here's another example. 8p plus 8p squared. You have to think before you add to make sure they're like or not. P and p squared. The variable is same, but the exponent don't match. One has a power of 2, the other has a 1. So this one is unlike terms. Something which is unlike cannot be combined or added. Let's try one more. Now in here, we have multiple terms, so we need to make sure before we combine, we need to make sure we're only combining the like terms. So here I have 5x and 2x I can combine, making it a 7x. Negative 3y and negative 5y I can combine, which can make it negative 8y. Now, negative 3 is the only number I have. I don't see any other number. That will stay as is. So my final answer looks like 7x by combining 5x and 2x, negative 8y by combining negative 3y and negative 5y, and I bring down the negative 3. I guess now we are ready to simplify the expression. This is our first expression, 4 times 6y plus 9 plus 7. Now, if you see the parenthesis, the first thing you need to do is use a distributive property. 4 times 6y will give you 24y. 4 times 9 will give you 36. Let's distribute first. We'll bring down the 7 as is. After the parenthesis is gone, you're going to look for like terms. In this case, 36 and 7 are the only like numbers because both are numbers. I'll bring down the 24y as is and I will add 36 plus 7 to get 43. And that's a simplified expression. Let's try another example. Negative 8 minus 3 times 2x plus 4. You need to make sure you follow order of operation as well. In this case, I'm not going to touch negative 3 first. I'm going to use the parentheses first. Negative 3 times 2x will give me negative 6x. Negative 3 times positive 4 will give me negative 12. Basically, I'm using a distributive property first. This is how I get negative 8 minus 6x minus 12. Now I'm looking for like terms, so negative 8 and negative 12 both are like. If I combine them, negative 8 plus negative 12, that will give me negative 20. So you have two choices. You can either write negative 20 minus bring down the 6x, or if you chose to write the variable first, you can put negative 6x minus 20. Either or will be correct. Let's try a few more examples using a distributive property again. Here we go. Let's start first distributing. Bring down the 3p. We'll first start with 4 times 4, 16. Then we will go 4 times negative 8p, which will give me negative 32p. So I'll bring down the 3p. 4 times 4, 16. And then 4 times negative 8p is a negative 32p. In here, 3p and negative 32p are the only like ones. Both have p in them. So these two are the ones you will combine. That will result in a negative 29p. Bring down the 16 as is. So if somebody chose to write 16 minus 29p, would be marked correct also. Here's another example. With the 2 parentheses, you have to distribute twice. Negative 4 times 5y, negative 20y. Negative 4 times negative 7, positive 28. 3 times 2y, 6y. 3 times negative 5, negative 15. Let's get that first. Here we have 2 y's and we have 2 numbers. I'm going to combine the letters together and the numbers together. Negative 20y and 6y will result in negative 14y. 28 minus 15 will give me positive 13. Your final answer will be negative 14y plus 13. The whole idea is to make sure that you are combining the y's together and the numbers together. Let's try a few more on simplifying. 6 times 3p minus 2 minus 5p plus 1. Let's first start distributing. 6 times 3p will give me 18p. 6 times negative 2 will give me negative 12. Even though I have a no number here, you can put imaginary 1. Negative 1 times 5p will be negative 5p, or negative 1 times 5p is still negative 5p. Negative times positive 1 is a negative 1. Now let's combine the p's. So I have 18p and a negative 5p. When I combine, I get 13p. Let's combine negative 12 and negative 1. That will give me negative 13. Your final answer will be 13p minus 13. Let's try one more. Negative 2 times 3r minus 4 minus 6 times r plus 2r minus 5. Here we are distributing again. Negative 2 times 3r is a negative 6r. Negative 2 times negative 4 is a positive 8. Negative times positive, negative 6. Negative times negative r, positive r. Let's bring down the 2r and minus 5 as is. Here I'm going to combine all my r's together. Doesn't matter in which order you combine. So if I combine r and 2r first, which will give me 3r, negative 6r plus 3r should give me negative 3r. I can combine the numbers in whichever order I want. 8 minus 6 is 2. 2 and negative 5 will give me negative 3. The final answer will be negative 3r minus 3. If needed, please go and repeat the video on simplifying expressions.